Okay, now to perform dividing a polynomial. Okay, this is a section where if you are dividing a polynomial with a monomial, this is a simple term, it will be done quite easily because we can split the thing up part by part, just like breaking up things into pieces like Lego. Okay, so if that only happens if the denominator is made of monomial. So monomial means there's only one term over here. This is trinomial. This is not monomial. Okay, the upper one is trinomial because we have one. Okay, this is considered one term, two terms, three terms. Even the constant value is considered as one term. So this is trinomial. This is monomial. Monomial only one alone. Okay, so now we're gonna split the thing up into three sections, which is negative 12 of this a square, a cubic divided by 3a's. This one divide 36a divided by 3a's, and this as well. So each of them break up into pieces, and now we can divide it one by one using this. So what we have over here is this will be 12 divided by 3, so you get negative 4a square. Now since this a power 3 and a kind of get cut off already, so it divides, cut off, so we go down one power below, so this turn into a square, this turn into 12. Okay, after 36 divided by 3 we get 12 over here. This one will simplify with the 3 over here, divide thing, we get 5 divided by 8. Okay, now this is if the case is monomial. Now what if this cases is made up from even larger groups of polynomial? Now if it's larger group, then the long division we're going to have sections like this. So you're going to have first possibly you're going to have qx over here, and the last part over here is considered as a remainder. So whatever remain in the division will be putting at the back, so this side. So this is actually the general forms of the long division. Okay, again, I do not encourage you people to memorize this formula. Okay, never ever memorize things like this, just for your reference. Okay, so now you're going to go for this long division. Okay, we're going to go for long division and see. I'm going to show you some example how it is done. Okay, now this is before we go into the actual what we call this long division. So long division will going to happen if the power over here is larger than the below. So for this case, I'm going to show you some variation of the simplification for polynomial. So there's not necessarily you have to use long division all the time, but instead you can choose the other way around to make it more simple. Okay, like this, we have x minus 2 divided by x squared minus 4x plus 4. So as we can see, the polynomial power from this one is lower than the below. So the denominator is in a greater power than the above. So in this case, we do not need to use long division, but instead we try to factor if it can be factored. The denominator over here. So we try to factorize this thing, and it seems that it's possible to factorize since this is negative 4x with 4 over here. So we can change it into factorize the thing into x minus 2. X minus 2 over here. So from this fraction over here, what we can see is we can cancel out one of them over here. This one we can cancel out, it turn into 1 divided by x minus 2. So which is much simpler compared to using long division. Now we look at the situation where we're going to use long division. So this is a case, okay, as you can see, the denominator, which is x minus 2, the one that at low has a lower power compared to the upper denominator. So here, okay, now situation like this, we can put the thing in the form like the normal way we do it in the classical way, dividing the numbers. So the nominator, we're going to put it at this side, so it becomes x squared minus 4x plus 4, while the denominator will be putting at the left hand side over here. Now what actually we do is, the multiplication step are same as a normal way of doing the division for numbers. It's the same. So as we can see, this is x squared minus 4x plus 4. So this is x minus 2. How many times of this we're gonna get you x squared? So how many times this x minus 2, we're gonna get you x squared over here. So what we did is just simply put an x over here. Actually the x should be putting at this in the middle section over this side, due to the what we call this equation setting, so it's a bit hard to drag it over here. We cannot get off a bit, drift off to the side, so it's okay. So when we put x over here, multiply with this x minus 2, what we have is this will turn into x multiplied with this, become x squared. This multiplied with 2, negative 2x, it turn into this one, negative 2x. So x minus multiply with negative 2, we get negative 2x over here. Now classical way, when we have the terms below this nominator, usually the process will be subtraction. So we're gonna subtract from the above, this one over here. So this and this will cancel each other out, gone. Negative 4x with this one, so negative 4x minus negative 2x is actually negative 4 plus 2x. So it turns into negative 2x after you take this with this. So negative 4x plus 2x, it becomes negative 2x. And the remainder over here, we're going to drag it down. So it follows. Okay. Now, we have the term over here and we have the terms over here. What multiply with x minus 2 will get you the result of negative 2x plus 4. Of course it's negative 2. So when you multiply with negative 2 over here, what we have is negative 2 multiply this, we get negative 2x. Negative 2 times this will become positive 4x. So if you can see above and below, using the classical way again, procedure will be the above will deduct with the one below. So subtract here. You get precisely 0, nothing. So there's no remainder. Now if the case that there's no remainder, it's much easy for us, since we get our long division result as x minus 2 only. So this is x minus 2 only, this is the result. Okay, now this is the outcome of the long division, x minus 2, that's it. There is no remainder. Now in the case where you have a bit, longer types of equation, okay, again the rules are simple. The nominator power must be greater than the denominator. So this is power 3, this is power 2 for the polynomial. So you can use this approach to do the division, long division. Okay, now what we see over here, we set the thing up like this. Okay, we have 4x squared and this thing, put it inside here, and we have the denominator x squared minus x plus 1. So now we're going to do the comparison. What actually multiply with this x squared gets you the answer of 4x power 3. How many times will this multiply will get 4x power 3? So just add 4x. So when 4x multiply with this, you get 4x power 3. Okay, so when this thing multiply with this, we get 4x power 3. This one, 4x multiply with this, we get negative 4x squared. 4x multiply with this one, we get 4x. So again, normal procedure, follow the gravity down. So this we're gonna do the deduction. Okay, we're gonna deduct, subtract, you call it whatever you call this thing. So this will cancel out. This negative 3x minus negative 4, so it become positive. So it become 3 plus 4x squared. 3x squared plus 4x squared. So this we get 7x squared. And this one instead we get the negative side. Negative 3x minus positive 4x. So it become negative 3x minus 4x. It become negative 7x. Remainder copy down. Okay. So now we have the terms looking like this. We're gonna figure a way what multiply this term to get the result as 7x squared at the front, the head over here. That's all. Now if you think of it, just simply multiply 7, that's it. So you multiply 7 into it, we get 7x squared. 7 with this, negative 7x, and 7 with what? 7. So the upper and also the below are equal. So you get no remainder. And your result will be just 4x plus 7 because there is no remainder over here. So according to the general forms of this long division, this is what we get, 4x plus 7, that's it. Okay, so those are the some example I want to show over here.